Okay, so to find the arc length when the angle is in radians, there's a relationship here that says your angle, your theta in radians, is equal to S is the variable that we use for arc length, S divided by R, and R is, of course, the radius. Okay, so theta in radians, the angle in radians, is equal to the arc length divided by the radius, S divided by R. Well, if we want to know the arc length, then we just need to solve that equation there for S. Okay, we need to solve that equation for S. So right now, S is being divided by R. So to get S by itself, we multiply both sides of this equation by R. So that says that S is equal to R, the radius, times theta, which is an angle in radians. Okay, so I'm going to label these pieces again right here. S is arc length. R is the radius of the circle. And theta is the angle in radians. So S equals R theta is a new way that we can solve for arc length. Don't forget, well, I'll remind you of the arc length formula with degrees here in a minute. Let's just use the new one for this example. Okay. I just wanted to show you where it comes from. Okay, so that theta equals S over R, not super important. The important part is S equals R times theta. Okay, S equals R times theta is the important thing. The arc length is equal to the radius times the angle in radians. So if they give us this circle here, the radius is 18 feet. The angle is 13 pi over 12. I know that's radians for two reasons. A, it doesn't have a degree symbol. And B, it has a pi in it. 9 times out of 10, if it has a pi, that's an angle in radians. So that means that I can calculate this simply by using S equals R times theta. 13 times 13 pi over 12. Now, initially, all I'm going to do is I'm going to multiply and divide everything but the pi. And I'm going to make that a fraction. So that's 39. I'm going to put the pi back in it. I just won't put it in my calculator because it'll multiply it out and it won't let me turn it into a fraction. 39 pi over 2 feet is the exact answer. If it gives you a decimal, then you multiply that by pi and round to the nearest tenth, so 61.3. Okay, so it's really, really easy. When your angle is in radians, you just take the radius and multiply by that angle in radians. If you want the exact answer, you multiply and divide everything but the pi, and then put the pi back in your answer. If you need a decimal, then you just multiply everything out, including the pi. All right, now, if the angle is in degrees, you can find arc length like we did before. Let's remind ourselves of how we found arc length before when it was in degrees. Remember, think about the fact that arc length is a portion of the outside of that circle. The outside of the circle, what do we call that? What do we call when we go all the way around the outside of the circle? Circumference, right? It's a portion of the circumference. So in degrees, we would put theta over 360 because that gives us our portion times circumference is 2 pi r. So if it's in degrees, you can still use that formula. Or we now know how to convert degrees to radians. We take our angle and we multiply it by pi over 180. Okay, this is an angle in degrees. We multiply by pi over 180. That'll give us theta in radians. And we plug that into S equals R times theta. I don't care which one you use if it's in degrees. If you want to use the old method and just put it over 360 and multiply by 2 pi r, that's fine. Or if you want to convert your degrees to radians and then multiply by the radius, that is fine as well. It's essentially the same difference. It is essentially the same difference because if we look at this equation, what happens? 2 over 360, that's 1 over 180. Okay, it really is the same equation. It's just looking at it from two different perspectives. So either way, but if it's in radians, use S equals R times theta. It's really easy. Just R times theta, multiply it out, leave the pi. Okay. If it's in degrees, either use the old formula or convert your degrees to radians and multiply by the radius.